So continuing with the third chapter that we will discuss, that is today we will discuss adiabatic process, that is a reversible and irreversible adiabatic process. So TS and HS diagram representation of the adiabatic process, and initial condition of steam is superheated and final condition of steam is a wet steam. Okay. So as you can see here, so this is your TS diagram. In the TS diagram, this is your constant pressure line P1 and this is your constant pressure line P2. Okay, state 1 will be represented at the wet steam region at the constant pressure P1, and when it will be expand. So when it will be expanded, that is your reversible adiabatic process, means isentropic process. The isentropic means constant entropy process. It will be a straight line, and it will be the state 2 will be at the pressure P2. What is your drainage fraction? Drainage fraction is your X2. Then if it will be irreversible process, then some of the losses will be there. The S1 not be is equal to S2. So that 1 to 2, this process will be represented as a irreversible process, irreversible adiabatic, and here the straight line is a reversible adiabatic. So here also in HS diagram, if you see, this is your pressure P1 and this is your pressure P2. State 1 will be represented at the superheated region, that was your state 1 superheated steam. So when it will be expand in the isentropic way, then it will be the 1 to 2s is your reversible adiabatic expansion of the steam, and in the 1 to 2 it is your irreversible expansion of the steam. So this way you can represent reversible and irreversible process of adiabatic process. Then if you go for the work done, then in the work done in the adiabatic process, what will be there? The heat transfer will be 0. So we know that del Q is equal to du plus del W. Del Q is equal to, you know, that du plus del W. So what is your del W? Del W is equal to del Q minus du. So though heat transfer will be 0, then dW, the work done is equal to minus of change in internal energy. So that will be a U superheated minus U1 minus U2. So du minus of du means minus of U2 minus U1. So minus of U2 minus U1, you can write U1 minus U2. Then work done from under, that is your U1 minus U2. Okay. So what is your internal energy? Enthalpy H minus PV. Though according to the state 1 and state 2, you can write the process. And heat transfer, that is your del Q0, change in internal energy for a reversible process, ds change in entropy is equal to 0. That means we can say S2 is equal to S1. Okay. And if it will be irreversible process, then ds is equal to S2 minus S1. For reversible process, S2 is equal to S1. Then we will go for isothermal process, PV, TS and HS representation. So in the pressure PV diagram, this is your constant temperature line. See, this is your constant temperature line. So state 1 is your what? Wet steam. So when you are heating at a constant temperature, it becomes superheated steam. That is your here at pressure P2. State 1 is your pressure P1. So likewise you can see the constant temperature line in the PV diagram and constant temperature line in the TS diagram. So it will be a horizontal line because the constant temperature line is horizontal. So initial condition of steam is wet steam, I mean drainage fraction X1, final condition is superheated steam. So if you go for the HS diagram, so this is your what? Constant temperature line, and state 1 is at pressure P1 and state 2 is at pressure P2. So that 1 to 2 is your what? That is your constant temperature heating. So if you have to calculate the heat transfer, then what is the heat transfer? So del Q is equal to T into integration to T into superheated minus T into S2 minus del Q is equal to TdS. So no, because ds is equal to del Q by T, then del Q is equal to T into ds. So Q is equal to T into integration of ds, that is your temperature into S2 minus S1. Yeah. So this way you can calculate what? Heat transfer.